All right, so they want us to find NQ. They want us to find this whole thing, NQ. They tell us that RL is 21, and they tell us that SQ SQ is 4. We want to know what NQ is. We want to know what NQ is. From the median theorem, we can know that NS is equal to 2/3 NQ. Well, let me tell you this. What do we know about NS and SQ? Correct. We know that NS plus SQ is equal to NQ. So if that's the case, let's go ahead and work this out just like this. If NS is equal to 2/3 NQ, let's plug that in right here. We have 2/3 NQ plus SQ is equal to NQ. What do we have to do to solve for SQ right here? Correct. We minus 2/3 NQ minus 2/3 NQ, and we end up with SQ is equal to, what is 1 minus 2/3? That is 1/3 NQ. So we know now that SQ is equal to 1/3 NQ. Do we know what SQ is? Yes, we know what SQ is. It's right here. So let's plug that in. 4 is equal to 1/3 NQ. What do we have to do to solve for NQ? We do the opposite, correct, of what's happening to NQ, which is to divide by 1/3. And what happens when you multiply or divide by fractions? It's keep it, change it, flip it. So when you multiply or divide here, we need to make sure that we do the reciprocal. So we're going to multiply by the reciprocal, because you do not divide fractions, you multiply fractions. And we end up with 12 is equal to NQ. That's how we go about solving that. I'm going to give you guys a chance to be able to copy this down. I want you to draw out the whole thing, and then make sure you draw all of that out. So go ahead and pause the video if you need to until everybody is done doing that, and then we'll go on to the next problem. All right, first things first, draw this out. And I'm going to give you time to draw that out by allowing him to pause the video. And then as soon as that's all done, you're going to go ahead and follow along again. So they want us to find KW. They want us to find KW. That is this whole thing. They gave us LX, they give us LX, this right here. They give us LX, and then they give us ZW right here. So from our last time that we did this, from our theorem, we know that KZ is equal to 2/3 KW. But the last time we solved this, we also know that ZW is equal to 1/3 KW. So this time we're going to use this. We don't need to work through that whole process again of doing the algebra. Since we already know this, let's use this again. So if ZW is equal to 1/3 KW, let's plug in ZW. And we get 7 is equal to 1/3 KW. And what do we do here? We multiply by the reciprocal, which is 3/1. And you end up with 21 is equal to KW. And I'm going really fast here, guys. I would not normally go this fast, but I need to get myself up to the hospital. My wife is dehydrated, and they're just going to end up keeping her. So I didn't make this ahead of time like I normally would. So I'm making it right now in third period, so you can have it fourth period, but I also need to take off. All right, so that's what's going on. And that's why I'm going so fast and just asking the sub to pause the video when he needs to. Thank you, Mario. All right, now problem-solving application. A sculptor shaping a triangular piece of iron that will balance on the point of a cone. At what coordinates will the triangular region balance? So here's the thing. We need to find the midpoint of these points. Do we know how to find the midpoint of this? From 6 to 10, how far is that? It's 2. It's 4, correct. So what's half of that? 2. So we come over here, 2. And then from 6 to 7, how far is that? 1. So how far do we go up? Half. So right here. So in order to find the midpoint, we just went over, we know that this is 4, so we went over 2. And then we know that this is 1, so we go up a half, and that puts us there. And then we draw from that point to here. Mario, go ahead and pause the video here so that the students have a chance to be able to graph this out. If they need graph paper, there might not be enough, so go ahead and allow a student to grab some and go make copies. And in the meantime, while that student is making the copies, the rest of the students can maybe just try graphing this out themselves or working on the worksheets. So the next thing that we need to do is find the midpoint of another one. So let's find this midpoint, this one right here. How far down is this? That's 1, 2, 3, 4. So where's the midpoint going to be? Right there. How far over is this? 1, 2. So we go over 1. We went down 2 over 1. So right here is the midpoint of that. And then we're going to go from that midpoint to the center of the triangle, or that angle over there. And that allows us then to know where those 2 points cross is the region at which it will balance. So this centroid right here for the midpoints of the triangle is where the triangle will balance. And where does that happen to be? How far over is that? That is 8, comma, and how far up is that? 5. So 8, 5 is where the triangle will balance. It's easy to work this out when you have coordinate points to be able to, and you have it on there on a good drawing to be able to find out where they balance. Example 2, and we're going to go ahead and do this again. Mario, go ahead and pause this so that the students can be able to copy this down. And then we're going to do the very same thing. Actually, how about I pause this, or you pause this, and then as soon as everybody is close to or has found out where the points are, then you go ahead and start playing the video and see if they are correct. If anybody needs help, ask for help from another student if you're lost. Thank you. So we need to find the midpoint. So how far up do we have to go right here? I want to find the midpoint of this line. So we go up 4. So how far up do we actually need to go? 2. Let's pick the blue line there. We go up 2. And how far to the right do we have to go? 1, 2, 3. So how far do we actually need to go? 1.5. So that puts us right here. So that is the midpoint of that line. And now we're going to draw in from this point to the center of that angle there. And now somewhere here we know is on that line is going to be the midpoint of this triangle. So we go ahead and let's find how far down do we have to go here? 8. So how far up should we go? 4. So somewhere on this line is going to be where it crosses. And we actually really don't even need to find the next point because we know it's going to be somewhere horizontally on this point, and right where it meets is the point that we need to be at. So let's go ahead and draw that in. So we draw that all the way across to that angle, and it turns out that it is this point right here is the center of the triangle. And what point is that? That is, I'll call that P. No, we can't do P. We'll call that C for center. Is over how far? 3, comma, up how far? 4. Is where the triangle balances. And this is the altitude, and I'm going to go over this again. We went over this yesterday. Well, some of us went over it yesterday, not all of us. But to find the altitude of the triangle, what is an altitude? That's the distance, or that's the height of the triangle. So this YQ is an altitude. That's the height of the triangle. If RS is the base, then the altitude or the height of the triangle is YQ. Mario, go ahead and pause the video so that everybody has a chance to be able to copy that down. When they've got it copied, go ahead and hit play. Thank you. All right, so YQ is an altitude, but it turns out that if RQ, if we want RQ to be our base, what is the altitude of RQ? And it turns out that the altitude of RQ is ZS. The altitude is always perpendicular to the base, passing through the opposite point. Passing through the opposite point. So what is that's the altitude to RS, is perpendicular to RS, passing through point Q. And we have one more point that we need to pass through, which is R. So that point would be opposite of, or needs to be perpendicular to QS. We follow QS until we get to here, and at this point is where that perpendicular line passes through QS and R, and that gives us the angle or the altitude XR for base QS. So altitude is the height of the triangle for a given base. And every triangle has 3 altitudes, and if you extend those altitudes so that they become lines and not just the distance YQ or ZS or RX, but if you make them into lines, they all end up coming into contact in one point P. All right? PS is not the altitude, ZS is, but PS is the line in which will come in contact with all the other lines that the altitude follows, if that makes any sense. And this point of concurrency is called the orthocenter of a triangle. All right, orthocenter of a triangle is where all the altitudes meet. The height of a triangle is the length of an altitude. Remember that I had mentioned that? When you're trying to find the height of a triangle, you find its altitude. Find the orthocenter of a triangle. So we need to first find the perpendicular lines to this that pass through point Z. All right, so everybody go ahead and pause and let's draw this out. And as soon as it's unpaused, go ahead and hit play, Mario. Now, first things first, to find the line perpendicular through Y-axis, that's really easy to do. Go like this. And we're going to extend that on back this way. Now we need to find the point that is perpendicular So we're going to extend this line here. Boom, 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 boom. Well, this one was really easy. We have this one. And then we are going to need to find the equation for this line, yz, and find out what the slope of this line is actually. That's what we need to do, find the slope of this line. So how far to the right do we go? And we go over 1, 2, 3, 4. So y, z, so m, we'll say m sub y, z is equal to, it's rise over run, and the run was 4, we said, 1, 2, 3, 4, and the height is 1, 2, 3, 4, 5. 5. So we need to find the perpendicular equation passing through this point. So to find the perpendicular line passing through that point, we say y equals mx plus b. Actually, we don't want to do that one, sorry. We want point slope form. So that's going to be y minus y1 is equal to m times by x minus x1. And then we go ahead. How do you find the perpendicular line to yz? Yes, whoever said it or was thinking it, you need to find the negative reciprocal. So the negative reciprocal would be negative 4/5. That would be our slope for this point. So we say y minus y1 is equal to negative 4/5 x minus x1. But what is y1 and x1? Do we know a point? Yes, we know this point y. And what is that? That is 3, 6. So we plug that into our equation. Y minus 6 is equal to negative 4/5 x minus 3. So then we go ahead and plug that in. Actually, we don't even need to plug that in. Once we have this point, this m, we know that it's negative 4, 5. So let's do that. Let's go down 4. 1, 2, 3, 4, and over 5. 1, 2, 3, 4, 5. All right, guys, I made a mistake here. I said that we needed the perpendicular line to this going through this point, and we can't do that. What I wanted to know, if I have this line and it extends this way, and it keeps going this way, at some point this is going to make contact here. And I need the perpendicular line to this that is passing through this. Or perpendicular to that, which would be something like that right here. So I need to use point X. So I start here and I use that. So if it's down 4, let's go up 4. 1, 2, 3, 4, and to the left 5. 1, 2, 3, 4, 5. One, 2, 3, 4. 1, 2, 3, 4, 5. Rise over run. negative reciprocal. Oh, we go to the right. 1, 2, 3, 4, 5. And then we go down 4. Oh, this is negative. That's what's going on. This is a negative slope right here, right, guys? And I forgot that. So this should be positive. That's why I'm getting all confused. So I get this. We start again. We go up. How much? We go up 4. 1, 2, 3, 4. And then we go over to the right 5. 1, 2, 3, 4, 5. So through this point, right there, is going to be this, the line that we need. Now that becomes perpendicular to YZ. And it turns out that this is the point that we are looking at. And that is going to be 6.7. 6.7 to the right, and up 1 would be where that lies. All right, so that'll be enough for today, and I will go back over example 3 or an example 3 tomorrow, but go ahead and get to working on your homework. All right, thank you guys.